Today we have two speakers, Dr. Jana Hirschtick and Dr. Steve Cook. They'll be talking about the longitudinal association between exclusive and dual use of ends and cigarettes and cardiovascular disease among adults, key findings and methodological considerations. Just some housekeeping before we get started with the bios and the presentations. The presentation will be about 40 minutes, and there will be about 20 minutes for Q&A for a total of 1 hour. Participants will be muted upon entry and may only be muted with the host permission. You can submit your questions at any time using the Q&A feature that you would see on your Zoom window. After the webinar ends, you'll be directed to a brief 5-question survey. So please complete the survey. It'll help us evaluate our webinar series. So again, welcome everyone. I would like to introduce the speakers. The first speaker will be Jana Hirschtick. She's a social epidemiologist here at the University of Michigan with a PhD in epidemiology from the University of Illinois at Chicago and MPH from Johns Hopkins University. Her research spans multiple topics with a common goal of practicing consequential epidemiology that can be directly translated to improve public health. Her tobacco-related research focuses on the health equity impact of tobacco product use, related health outcomes, and tobacco control policies as a part of our CAsToR Center. Steve Cook is a sociologist at the University of Michigan with a PhD in sociology from the University of Toronto and an MA in criminology from the University of Toronto and an MA in sociology with a specialization in program and policy evaluation from the University of Western Ontario. His research explores the intersection between criminology and public health and social problems related to mental health, substance abuse, their overlap, and other risky and illicit behaviors. His tobacco-related research with CAsToR focuses on the analysis of prospective longitudinal data to better understand the role of e-cigarettes and cardiovascular and respiratory health outcomes among adults, as well as parallel studies with youth. He has also examined the association between menthol cigarette use and smoking cessation and is currently in the final stages of an analysis examining the time-varying associations between coupon use and smoking cessation among adult smokers in the United States. With that, I'll ask Jana Hirschtick to start when she is ready. Thank you everyone for coming.
Thanks, Ritesh, and welcome everybody. As Ritesh mentioned, I will be co-presenting with Steve today, and we'll be covering longitudinal associations between exclusive and dual use of ends and cigarettes and cardiovascular disease. So for our agenda, I will start by providing an overview of our study and some key findings, and then hand it over to Steve to discuss some key methodological issues, including reverse causation, confounding, attrition, and weighting. So to dive right in here, as we know, cigarette use is a leading risk factor for cardiovascular disease. But the association between electronic nicotine delivery systems, or ENDS, and cardiovascular disease is really not well understood. Most existing studies on this topic are cross-sectional and do not account for cigarette smoking history. So our guiding question in our analyses on this topic is, does ENDS use cause adverse health effects? And for this analysis in particular, we were interested in adverse cardiovascular health effects. And our objective is to assess prospective associations between exclusive and dual use of ENDS and cigarettes with myocardial infarction or heart attack and stroke among US adults. We used the Population Assessment of Tobacco and Health Study, Waves 1 through 5, which spanned 2013 to 2019. We analyzed the incidence of myocardial infarction or MI or stroke over that 5-year follow-up period for adults aged 40 and over. We excluded respondents reporting an MI or stroke event prior to baseline. And respondents had to complete at least one wave of follow-up. So we had a minimum of 2 data points on everyone. For our MI and stroke samples, we had about 11,000 respondents for each analysis. In terms of quantifying our outcomes, we use these 2 questions. In the past 12 months, has a doctor, nurse, or other health professional told you that you had a heart attack or needed bypass surgery? Or in the past 12 months, has a doctor, nurse, or other health professional told you that you had a stroke? In terms of our primary exposure, we first quantified current ENDS or cigarette use. And for ENDS, we restricted it to established users. Those are users who said they've ever used ENDS fairly regularly and reported now using ENDS every day or some days. And similarly for cigarettes, we restricted it to established users, those who smoked at least 100 cigarettes in their lifetime and reported now smoking every day or some days. And then we used those 2 indicators to create a 4-category primary exposure variable that included a non-current use category, and that was never users or former users of either product, exclusive cigarette use, exclusive ENDS use, and cigarette and ENDS dual use. We included that 4-category variable as a time-varying exposure and lagged it by 1 wave to ensure that our exposure preceded the outcome. So in other words, we evaluated that exposure at wave T-1 with the outcome at wave T. We controlled for a number of potential confounders at baseline, including demographics like age, sex, race, ethnicity, and highest educational attainment, and some clinical risk factors such as family history of premature heart disease, diagnosed hypertension, and diagnosed diabetes. And it was also really important for us to account for smoking history, and we did that in 2 ways. The first was including an indicator for former established smoker, and that was for individuals who had smoked at least 100 cigarettes in their lifetime but reported no current use at wave 1. We also calculated cigarette pack years for all adults who either currently or formerly smoked, and we calculated it by multiplying their reported baseline duration of cigarette smoking in years by their average pack smoked per day at wave 1. And we did include never smokers in that calculation and coded them with a value of 0 pack years. We used discrete time survival models to estimate prospective associations between exclusive and dual use of ENDS and cigarettes and newly diagnosed MI and stroke across the 4 follow-up waves. And we ran models 2 ways with both non-current use and exclusive cigarette use as the referent category. Steve will discuss the path weights in more detail, but we decided to use the wave 1 weights as opposed to the path all waves weights for 2 reasons. First, it allowed us to keep a representative sample of the US population at the time of wave 1. And importantly, it also allowed us to keep respondents who did not complete all waves of follow-up, which is required for the all waves weight. So that's how we were able to keep people with at least 2 data points. So before diving into the model results, I want to walk you through some of the descriptive findings. This is baseline current use status, so our primary 4-category exposure variable. And as you can see, the majority of respondents, 84%, were non-current users. And remember, that includes never users of cigarettes and ENDS or former users. 14% were exclusively smoking cigarettes, 0.6% were exclusively using ENDS, and 1% were dual users of cigarettes and ENDS. In terms of our baseline historical cigarette use, I included 2 measures here. So the first is that indicator for former established smoker, and you'll see that about 1/4 of our respondents were former established smokers. When we add that value to the current established smoker category, we get about 38% who are either former or current smokers. And among that group, their mean pack years value was 26.4. So now I want to take a little time to compare our 4 user groups across some demographics so we have a better understanding of how they differ before diving into the model results. So first, here we see that adults who did not use cigarettes or ends in the dark blue bar were older than adults who used cigarettes and or ends. So the non-current use category, the mean age was 58 years, compared to about 52 or 53 years for adults who either used cigarettes, ends, or both. Adults who used ends, either exclusively or in combination with cigarettes, so those 2 dark blue bars, were more likely to be female, about 60%, than adults who exclusively smoked cigarettes, which was closer to 48% female. Adults who use cigarettes were more likely to be non-Hispanic Black. So you can see in the red box, 16% of exclusive cigarette users were non-Hispanic Black, while adults who used ends, either exclusively or in combination with cigarettes, were more likely to be non-Hispanic White, over 80%. Nearly 60% of adults who exclusively smoked cigarettes had a high school education or less. And the other user categories had a smaller proportion. So for example, exclusive ends users, about 46% had a high school education or less, and it was a similar proportion for dual users. Adults who exclusively used ends or cigarettes had the highest historical cigarette pack years. So this one's really important in terms of interpreting our model findings. So actually the highest value of cigarette pack years was among our exclusive ends use category. And that's because the vast majority of adults over 40 in our sample who exclusively used ends were former smokers. So they had a cigarette pack year value of 29.5, followed by a value of 27.7 for our exclusive cigarette use category. The dual use category was lower. So adults who used both cigarettes and ends had a cigarette pack years value of 23.5. And then you'll see even the non-current use category has a pack year value of 6.7. And again, that's because that category includes former smokers who don't currently smoke cigarettes or use ends. So let's talk about the model results. Here we have the adjusted hazard ratios using first non-current use as the referent category. So for both outcomes, adults who exclusively used cigarettes had a significantly increased risk, about 2-fold, of myocardial infarction or stroke compared to non-current users. Adults who exclusively used ends did not have a significantly different risk of diagnosed MI or stroke versus non-current users, although you will probably notice the somewhat wide confidence intervals, and both Steve and I will touch on that a bit more later. And also adults who used both cigarettes and ends did not have a significantly different risk of diagnosed MI or stroke compared to non-current users, although both point estimates in this case were above 1. And I'll just add here that these models were adjusted for age, sex, race, ethnicity, education, that former smoking indicator, cigarette pack years, and the baseline clinical risk factors that I mentioned. So now walking through the results again, instead using the exclusive cigarette use as the referent category. And it mirrors what we just saw, basically. So the non-current users had a significantly reduced risk of MI or stroke compared to exclusive cigarette use. But the other categories, exclusive ends use, for example, those users did not have a significantly different risk of MI or stroke compared to exclusive cigarette users. And similarly, adults in the dual use category did not have a significantly different risk of heart attack or stroke than exclusive cigarette users. So just to recap our key findings, exclusive cigarette use increased the risk of both incident MI and stroke in our sample. But ends use, either exclusively or in combination with cigarettes, was not associated with the increased risk of MI or stroke over the 5-year follow-up period. So I want to talk about this a bit further, starting with the dual use category. The hazard ratio we found for dual use was elevated in our MI model, but the finding was not statistically significant. So our point estimate was 1.84, but you'll see a wide confidence interval there. So this may be due to a lack of power. We only had 274 adults who were in this dual use category at baseline. And there is some evidence that dual use is associated with greater nicotine and toxicant exposure compared to exclusive cigarette use. But you'll remember that the dual use group was also different in terms of historical smoking and demographics in our sample. So in our study, respondents using cigarettes and ends had a slightly lower cigarette pack years than respondents exclusively using cigarettes or ends. So we wouldn't necessarily expect an increased risk of MI or stroke among the dual use group relative at least to the exclusive cigarette user group. And then in terms of our ends use findings, we did not find that ends use significantly increased the risk of MI or stroke, although you'll remember that the confidence intervals were wide and the point estimates were actually in different directions across the two models. So again, this could be a power issue. We had a small number of adults who were exclusively using ends at baseline, 174. Ends may be an important harm reduction tool to reduce the risk of cardiovascular disease for cigarette smokers, but we really need more studies, both with a larger sample size of ends users and a longer follow-up period beyond our 5-year mark. So with that, I will hand it over to Steve to get into some of our key methodological issues and considerations. And Steve, you're still muted.
There you go. Can you hear me now? All right.
Yes.
All right. Hi, everybody. Thank you, Jana. For this section of the talk, I'm going to discuss some of the methodological issues and considerations that we thought quite a lot about in our research. We decided that in addition to just describing the results from the study, it made sense to provide some additional methods, details about why we made the decisions we made, and some of the key issues facing research in this field. We hope that in so doing, the conversation will move forward, and as more time passes and more data becomes available, we will have the capacity to use these the setup in future studies. So the way that we're going to talk about these issues is that we're going to do it in 3 steps. I'm going to talk first about reverse causation. I'm then going to talk about the confounding effect of cigarette use. And finally, I'll talk about problems related to attrition and the weights and path. For each of these, I'll define the problem, give a little bit of detail. I'll then show an example related to the MI outcome using path data. I'll either use the baseline path data or I will use data from our study to kind of illustrate the nature of the problem. And then I'll talk about the, I'll end by talking about kind of how we approached it and how we tried to limit these issues. And then I'm going to end by having a quick discussion about some issues and methodological problems that aren't so easily remedied and that I think need to have a real think as we move forward. So the first issue is related to reverse causation. This issue has received quite a lot of attention in the academic literature, and I think most people are familiar with the concept, but I think it's worth highlighting just to make sure we're all on the same page. Without information on the timing of both the exposure and the outcome, it's simply not possible to know whether ends use came before or after the MI and stroke outcomes. The latter is actually quite possible given the many adults who use combustible tobacco products switch to ends after experiencing negative health outcomes. So in this example, people will get sick, they'll have an outcome, maybe a heart attack, and then they'll start using ends products. So it's important for research to try to think carefully about the way that we look at our exposure variable and our outcome. Reverse causation is a particularly big problem in cross-sectional studies. And it's especially studies that don't have information about the timing of the exposure and the outcome. So slide, Jana. So if you think about the PATH study in 2013 and 2014, It was the first wave of a prospective longitudinal data analysis or study, but at wave one, it's essentially a big cross-sectional study. We don't have information over time primarily, and if you were to have access to the public use data file, what you'll see is that out of the 32,320 adult respondents who are 18 or over at baseline, you'll find out that 643 of them had reported myocardial infarction or MI at baseline, right? And we have information on MI, so someone might be tempted to do an analysis where they looked at those 643 respondents who reported a heart attack and look at their end use, look at the association, and to write a paper. And the problem with the public use data file is there's no information on the timing of these events. And because wave one of PATH surveyed people between age 18 and 90, we should probably expect, without looking at any of the data, that a lot of these cases happened quite a long time ago. So one advantage of the restricted use data file is that we actually do have a little bit more information. We know the exact age of the respondents at baseline, and we also know the age of their heart attack. So when people had an MI outcome, they were asked a follow-up question: how old were you when you had the follow-up? Now, this variable, of course, has problems with recall bias. I would argue that people remember big life events fairly well, so they have a rough approximation of their age at their heart attack. But this isn't meant to be a detailed analysis. It's just meant to illustrate the nature of the problem of reverse causation. And so what we did is we simply subtracted the current age from the age of their heart attack to try to figure out approximately when these events happened. And when we do this, we find that 383 of the respondents, or 61.1%, reported the heart attack happening 6 or more years ago. This is roughly equivalent to 2008 or earlier. And as many of you know, ENDS products weren't available in the tobacco marketplace pre-2008. So for these 383 respondents, their heart attacks could not have been caused by ENDS use, because ENDS use didn't exist at that point in time. If you're doing the math and you notice that 383 divided by 643 is not precisely 61.1, when I have asterisks in these tables, we're using the wave one weighted data. So the weights are applied so the numbers aren't precise, but that's why they don't completely match up. But we know that 61.1% had that event. It couldn't have been caused by that. Now, we do know that starting about 2011 and 2012, ENDS use became popular in the marketplace. And so it's possible that these 140 respondents reported a heart attack within the last 3 years could have had, ENDS use exposure that was related to the outcome. So it's possible. This table doesn't tell us very much because it doesn't tell us how many people used ENDS products when they initiated ENDS, but it does tell us something about the timing of the outcome, and that is related to one of the fundamental issues, which is reverse causation. So next slide, Jana. So the second thing we did is we took the adult respondents who used ENDS and had a heart attack. So out of the 643 people, there were actually 37 people who reported a heart attack and reported current ENDS use. So we only have 35. If you look at the red part of this table, there's only 35. That's because 2 people had their information dropped on e-cigarette initiation. And so what we did is we added e-cigarette initiation to look at whether the ENDS use initiation occurred before or after the outcome. And you'll notice that out of the 35 people, 27 of those respondents, or almost 80%, reported their ENDS use initiation occurring after the outcome. ENDS use initiation occurred at the same time or before for 8 respondents. And those 8 respondents, you'll notice that it's lumped together as at the same time or before. We initially had this category divided up, but we had to collapse them together for issues about getting the data released from the enclave. So we would have had too few people. But the point of this is to illustrate the potential nature or potential problems associated with reverse causation with cross-sectional data. We need to know that the ENDS use comes before the outcome. Slide. And so for our approach to dealing with this issue, we did 3 separate things. Jana discussed this at the start, but I think it's worth reiterating, is that first we excluded individuals who reported experiencing the outcome at baseline. So in the example of MI, the 643 respondents reported the outcome were excluded from the analysis. And then we looked at the incidence of MI and stroke prospectively over the follow-up waves 2 through 5. So we analyzed them prospectively, and our outcome was structured that way. For our exposure variable, we lagged the ends use by 1 wave to ensure that the exposure preceded the outcome. So if someone had a heart attack at wave 3, we would be using their wave 2 ends use information, right? And we're doing this specifically to limit the issues with reverse causation. And that's how we try to minimize that issue. The second issue that we're confronted with is the confounding effect of cigarette smoking. Most adults, particularly those over 40, who we examined in this study, who use ENDS products are either currently smoking cigarettes, so current smokers or former smokers. And because so many of these respondents are current or former smokers, it's important to properly account for the risk due to their past cigarette use, smoking exposure, when trying to assess the independent risk from ENDS use. So to put it a different way, because most ENDS users are also current or former smokers, we need to disentangle the impact of their smoking history, their cigarette smoking history, from the impact of their ENDS use history. So we used tobacco use history, including their cigarette pack years, to try to figure this out. And this example comes directly from our data sets. You'll notice that the sample size is 11,031. This is again related to the MI outcome. And sorry, in this table we have, in the columns, we have no ENDS use and ENDS use. So we looked at ENDS use by their smoking status indicators. Jana presented kind of how we operationalize ENDS use at the start. This is slightly different, but it's to illustrate the point of how many people ENDS users actually are current or former smokers. So the first thing to note here is the prevalence is small, like Jana mentioned at the start. There's only 448 ENDS users at baseline. It's 1.6% of the population. Again, this is using the wave 1 weights. And then if you look at the proportion of those 404 respondents who smoke or current or former smokers, the vast majority are former or current smokers. So 44 respondents are never smokers, and the remaining number are either former or current smokers. And I know a lot of people are interested in kind of the impact among never smokers. So to stratify, only look at this, the impact of ENDS on never smokers. In this example, we'd only have 44 respondents, right? So that's why we can't really do that. What we're left with is a whole bunch of people who smoke. And, almost 2/3 of our sample are current smokers, ENDS users are current smokers, and only 1/3 are former smokers. But these individuals have significant histories of smoking, and we need to control for that and to deal with that, to look at the net effect or the independent contribution of ENDS use. And the final thing worth noting is cigarette pack years. Here we're comparing the cigarette pack years values of the 404 ENDS users who are current or former smokers compared to the 5,828 non-ENDS users who are either current or former smokers. And what you'll notice is that among the ENDS users, they had significantly higher pack years than among the non-ENDS users, current or former smokers. So it's telling us something about the ENDS users, especially in terms of their pack years. So the point of this is that we really need to think carefully about how we control for cigarette smoking when looking at ENDS use. The slide, Jana. So for our approach to dealing with the second issue is, first, we included cigarette smoking status as part of our exposure variable in the main analysis. We control for the effect of former, current, established smoker. So these are smokers who have smoked at least 100 cigarettes in their lifetime, but are non-current users at baseline. And we also controlled for cigarette pack years at baseline. Jana said this at the start, but it's worth reiterating that cigarette pack years is calculated by multiplying the duration of smoking by the average number of cigarettes per day while individuals smoke. So a person who smokes a pack a day, which is 20 cigarettes for a year, would have a pack years value of 20. A person who smoked a pack of cigarettes a day for 20 years would have a pack years value of 400. Non-adults who never smoked or non-established smokers were given a value of 0. And it is worth noting that we don't have years since quit in this analysis, but we have looked at it in other analyses and in sensitivity analyses, and we found that it didn't contribute to the specific paper, but people who are doing this study may also want to consider the impact of years since quit on these outcomes. So slide. So the third issue that we've been thinking about as a team is the issue related to attrition and weighting. As in all longitudinal studies, respondent attrition is an issue and it's something we need to take seriously. There's 32,320 adults interviewed at wave 1. By wave 5, there's much fewer respondents. The people who drop out count as attrition. In most longitudinal analyses, we assume or try to test to prove that attrition is random or completely random. I think we can be a bit critical of whether or not respondent attrition is truly done at random, but we have to think about the implications of this, and we have put a fair bit of effort into this. And attrition really matters as it relates to the weighting. The baseline weights ensure that the respondents are representative of the non-institutionalized US adult population at baseline. And this approach, which is what we use for our main analysis, we use all available information for each respondent, but this does not adjust for respondents who do not participate in the waves of follow-up. So in other words, we're really assuming here that the attrition is done at random. And we do this because we want to maximize the information we have on people. So take, for example, somebody who participates in waves 1, 2, and 3. In our approach, we include them in the first 3 waves of the study, and then they get right censored after that. But we do have information on that individual. If we were to use the all waves weight and restrict to the people who participate at all waves of outcome, what we're doing is that person gets completely removed from the data set, and then their attrition is adjusted for in the weight, right? So it's 2 different approaches. For the all waves weight, that's what they do. So you take away the people who are censored, who don't participate in all waves of the study. It's a smaller analytic sample, but the weights are adjusting for the characteristics of how they weighted in the first place. One further note about the all waves weights, and people can correct me if I'm wrong, who know a lot more about PATH than I do, is I think that they only adjust for the things that they use to construct the weights. So in other words, they're not taking into account death and other things that happen over the course of the study. They're taking into account things that they use to construct the weights in the first place. So slide, Jana. So to illustrate this example, this is actually a life table from our study. That's the MI outcome. It's the same analytic sample you'll see in the top left is 11,031 respondents. For those of you who aren't very familiar with life tables, in the rows, you have the waves of follow-up. And then in the columns, you have the people starting at that specific wave, whether or not they had the diagnosis or outcome, the censoring, and then the hazard, which is adjusted with weights. But what's important for our purposes is, over the course of the study, if you add up the diagnosis column, I think you get 280 respondents who had a heart attack at baseline. But what you see, it's a much larger number, is the numbers who are censored. These are individuals who we have some data on, but it's incomplete data. So the 802, what this means is there's 802 people who we have information on at wave 1 and 2, but we have no information on past wave 2. And this becomes an issue because we are making a big assumption by assuming that these people are missing at random. So if you were to sum these 3 together, the numbers that are in the box, you'll see there's about 2,605 respondents who are censored in the study. If we were to use the all waves weight, those 2,605 people disappear and the weights account a little bit for their missingness. So the question is, what do we do to resolve that issue? Slide, Jana. For our approach, we did use the wave 1 weights to ensure representativeness at baseline. We do realize that there's potential issues with attrition. So we did an analysis examining the impact of the attrition by comparing the characteristics at baseline for respondents who dropped out of the study versus those who did not. A couple of key notes from this attrition analysis is that we do find some socio-demographic differences for people who drop out versus those who don't. We find 0 difference based on the ends use variable. We're not finding a systematic bias that ends users are more likely to drop out of the study, which is encouraging for our results. We do find that cigarette users are slightly more likely to drop out of the study. And so it's something important to think about in terms of who's dropping out of the study. We did restrict our analysis to the longitudinal cohort using the all waves weight. and the results were nearly identical. The only thing that really changed substantively was that the estimate for cigarette use, it becomes slightly smaller, and the effect is like marginally smaller. The significance doesn't change, but I think that may be because of the attrition. But that's how we dealt with the problem, and we did a lot of sensitivity analyses. And in general, I think it's worth noting that as we've gone through this process, and there's so many methodological issues and different ways you can measure things, is that our approach is to try to do the analysis in many different ways with many different sensitivity analyses to make sure that the results aren't being driven by the methodological decisions we made. So we try to be very careful about this. So hopefully that's helpful. But that's how we did the analysis. We use wave one weights, but we do all analyses with the longitudinal cohort to try to make sure that the weights aren't making a difference. So slide. All right, so those are the three big methodological considerations that kind of like drove our selection to like discrete time models with flagging variables. There are some other important methodological considerations that are like less easily resolvable, but I think are important to mention and to talk about. First is the short duration of follow-up. This is a 5-year follow-up study. You may have noticed from the life table, there's like, I think 8,146 people who are censored at the last wave. What that means is that these respondents didn't experience the outcome of wave 5. We have no information of what happens after. It's possible that a few people had a MI or a stroke the next day, the next week, maybe the next year. We don't have that information. We don't know what happens after the follow-up. So we need longer time to follow up individuals. The short duration of follow-up, as Jana said earlier, is an issue. These effects may take longer to appear, but as of right now, we look at people up to wave 5. Short duration of follow-up is definitely an issue. The second issue is related to informative censoring. Informative censoring is a problem when respondents are lost because they may have actually experienced the event. And it is quite possible that people are having these events and not surviving in the study, which would bias our results. But to invalidate the ends finding, we not only have to have people, dying throughout the study, we'd have to have them disproportionately being ends users. So if ends users were disproportionately having heart attacks and dying and being in the study, maybe our results are systematically biased. But we're not finding that, and we don't think that that's probable in our analysis, partly because ends users tend to be a little bit younger. They tend to have slightly higher socioeconomic status, higher education, and other factors that are actually associated with lower risk of MI and stroke outcomes. But informative censoring is always a problem. It's often assumed in survival models and never really formally tested. But I think it's something that's important to mention because we should be thinking about it, taking it seriously, and trying to account for informative censoring if it in fact is there. The third issue, as Jan has already talked about, is related to statistical power and exposure time. Ends use was only reported by a small number of respondents. So altogether about 450, I think, at the first wave. And this may limit the power to detect an association, even if there is an association. We can't control how many people in a nationally representative sample smoke and use ends products. So that's something that's beyond our control. But it is a limitation of a study. We do have relatively wide confidence intervals. And I think that's important to consider. So moving forward, that's something we have to think about. It is worth noting that in parallel analyses looking at youth populations, we have the opposite problem. We have a lot of people using ends products and very few people smoking. What's interesting about that analysis is that we're still finding an effect of cigarette use, even though it's constrained by small numbers of people smoking. So we're still finding an effect of a small number of people. Here, we have a small number of people using ends products. We're not finding an effect. That doesn't mean it's not there. And I don't think that we can conclude that ends use doesn't have an effect. We should be cognizant of the importance of power. And we may also need longer exposure time to ends to fully understand the effect of ends use. This gets back to the duration of follow-up. Our study is very much the first longitudinal study, or one of the first longitudinal studies on the topic. More needs to be done. As time passes and as more people use ends products, we still have to update these analyses to look at the downstream health consequences. So I think that's important. And the other thing that's not actually listed here, but we need to think about, is we don't do a very good job of defining intensity and frequency of ends use. And for cigarettes, we know that cigarette pack years matters, we should be thinking about how to measure ENDS exposure, which takes into account not just their current use status, but also their intensity and frequency of use. And I think that will really help as we move forward. So yeah, things to think about.
Thanks, Steve. So I've just got one quick wrap-up slide, and then we can open it up for any questions the audience has. So just to wrap up, as Steve just walked you through, our study really should be interpreted in the context of the limitations that we discussed, but did try to address whenever possible. So we attempted to address issues with past smoking history of adults who use ENDS, which many of the ENDS users were past smokers, issues with reverse causation and attrition, as Steve mentioned. But we're not able to address things that are inherent to the sample. So there are a small number of adults 40 and over who use ENDS, and we used all the available follow-up time and path, but only 5 years were available to us at the time of the analysis. But despite those remaining limitations, we do feel that our study better addresses some of the methodological issues of previous studies and provides important information about the short-term or 5-year association between ENDS use and diagnosed cardiovascular disease. So with that, I will stop sharing my screen and I'm happy to open it up to questions.
Thank you, Jana and Steve, for a great presentation. So now we are going to read the questions that the audience are sending. We start with Adriana Perez. Are the results presented 1 year later, or when was the outcome measured?
So I'll briefly touch on this and then hand it over to Steve for the more technical details, but our exposure was lagged by 1 wave. So it's at least 1 year after the exposure that the outcome was measured, but it could have been at any course during the follow-up. Steve, is there anything you want to add to that?
Just in terms of the outcome, what we looked at, the example that I presented to the last part of the presentation was focused on MI. We also have the stroke data. There are 280 respondents who had a stroke between wave 2 and wave 5. We combined them at each period. So it's like a combination of the events that happened over time. So it was prospectively. So it's a relatively small number of cases. And I know that some other questions are probably going to point to issues of power. But that's the way the outcome is measured. So it's done over time. Does that make sense?
Thank you guys for a very great presentation. I have a question from Ken Warner. PAC years is a more important measure for cancer than CVD risk. Much of the smoking-related heart disease risk disappears after a few years post-quitting. Did you include both PAC years and years since quitting smoking in the regression analysis? Did you consider an interaction term? What did you find comparing PAC years and years since last smoked? Again, I appreciate that the small sample sizes maybe make this futile.
Right, so
Take it away, Steve.
Yeah, I'll attempt to answer this. It's a very good question. We spend a lot of time thinking about the functional form of PAC years. In this model, I think we included it as PAC years as a linear term, but we also included it as like in other functional forms, like as a quadratic term, meaning that it does take into account the fact that some people, that might not be a linear term. So we did have that. We also did add years since quit into the model. It becomes tricky to add years since quit into the model because we have a lot of people who are never smokers. So we tried to assess the impact of years since quit by looking at interaction terms. And we did that, and it didn't change our main focal results, which is why we don't have them here. But I think the point of like low sample size is definitely something that constrains our ability to do fancier models, which we have tried though.
Thank you. So we have a question from Jacqueline Avila. Thank you for a great presentation. Can you talk about the decision to only include individuals 40 and older, given that the end use is much lower in this group? Thanks.
Yeah, that one was kind of made for us by the path skip patterns. So in the later waves of path, they suppressed the outcome data of MI or stroke for people under 40, I think because they were so rare. So in order to keep our models consistent, we decided to restrict to adults 40 plus, which is a limitation. I will say that we have some parallel analyses going on with youth, and some of them include youth who age up into adulthood. So we'll hopefully be able to look at that group in those analyses.
And just to add on to what Jana said, we also have an analysis where we're looking at the association between ENDS use and hypertension. And in that analysis, we're using respondents who are 18 and over. So it does capture people who use much higher levels of ENDS use with a different outcome. And we find similar results, but it allows us, we have much more power because we have a lot more ENDS users in that analysis.
Great, thank you. Sapna Thakur has this question. Did the respondents use the same products in all follow-up waves? If not, how did you account for switching to other products in the follow-up?
You want to take that one, Steve?
Sure. I think the one question is accounting for, I'm not 100% sure what the respondent means or the question means regarding switching products. We look at ENDS products. We don't look at different types of ENDS products, if that's a question. So we're looking at ENDS use at follow-up. We look at switching in the sense of cigarettes to ENDS use because people can switch between those categories. That can be dual users or not dual users. We did not take into account systematically other patterns of use and switching. Our study is very much concentrated on the effect of ENDS use and not on the relative value of switching products, which I think if that's what the question is alluding to is a good question, whether or not a heavy smoker who switches to ENDS has a different outcome. So we didn't specifically study that. And in our study, we're very much focused on the effect of ENDS use within that 4-category exposure variable. And then we consider ENDS as like current use of ENDS, all types of ENDS combined. Jana's
I'll just add too that we did allow the exposure to time vary. So we are at least capturing at each wave their current use of ENDS and cigarettes and allowed that to vary across the study.
Thank you. We have a question and a comment from Ann Anderson. Great presentation, well planned and executed. Will the N change much in the next year or two? Is an ENDS use rising?
It could. I don't know how much we should expect it to change among adults over 40. But certainly we're seeing in youth and young adults, there was a rise, which, may be being impacted by COVID. But I think, especially because we started wave 1 in 2013, there was a very small number of adults using ENDS 40 plus. So I don't want to look for or encourage, an increase in that number, but we may have more power because ENDS use has increased in popularity over the past few years.
Great. Folks, if you have questions, please type them into the Q&A box. We'd appreciate your questions. There is a question from Cheryl Deutsch. I am sorry if I mispronounced your last name. What is the bottom line in your opinion? Is there any feeling that ENDS are safer than combustibles?
I was wondering if we were going to get this question. I think two things. It is encouraging, even despite all the limitations we talked about, that we did not see a significant association between ENDS use and diagnosed MI or stroke. But I just think, based on our one study and all the limitations of the data, it's too soon to make that conclusion.
Okay, please type your questions. There are no questions from the audience at the moment, but I do have a question for you both. I know you brought up the issue of intensity or frequency of use as important, and you did account for it in the pack years and so forth. But I'm curious on what was the frequency or intensity of use across the 4 exposure categories? maybe at baseline, because it seems like that might be critical for particularly dual users. And if you could, I know you did a great job of describing demographic differences across the 4 exposure groups, but it'd be nice to see some other information about how much folks are using across the 4 categories of exposure.
So we did look at cigarette pack years, which was our main measure of intensity and historical use across the 4 user groups. It was actually highest among exclusive ENDS users, because many of them were former smokers, followed by exclusive cigarette users, and then lower among the dual use category, which could explain our lack of findings for the dual use group, at least relative to exclusive cigarette smokers. Steve touched on this very briefly. Maybe now is a good time to talk a bit about why we were not able to include a measure of intensity for ENDS use, but it mostly has to do with kind of the rapidly changing nature of the ENDS available in the marketplace and how that's captured in PATH. But did you want to add anything, Steve? You're muted, Steve.
I don't know why I mute myself all the time, but I do. No, I think that's a really nice answer. One thing we could add is that we look at pack years at baseline. We also tried to, we allowed pack years to time vary. There's no reason it can't. But we tried to keep our models as clean as possible because pack years is fairly consistent. Like people who are smokers tend to not have their pack years change a lot over 4 years. But once we start allowing everything to time vary, then we're introducing potential issues around mediation and complicating what this actually means. So for simplicity, we did keep kind of a baseline cigarette pack years. In other analyses, we've tried to look at intensity as opposed to pack years, because pack years is obviously a little bit dependent on how old you are. It is worth noting that we center age in all our models because age is going to be a little bit collinear with pack years. So we're trying the best we can to limit, some of those problems in our modeling. But it's a work in progress. It's tricky to model all these things right. And regardless of what we've done in these sensitivity analyses, the main results are staying the same, which gives us confidence kind of in what our findings mean.
We have a question from Elise DeVito. Within combustible cigarette smokers, in the literature in general, is there an understanding of how many years of smoking usually precedes increased risk of MI? Is the risk increase right away, or is it cumulative with prolonged use? I ask because given limited availability of ENDS prior to 2008, as presenters mentioned, ENDS use group likely had shorter duration of lifetime. The ENDS use group likely had shorter duration of lifetime use compared to combustible cigarette smokers.
Yeah, that's a great point. When we were starting our analysis, we had the same question and actually roped in a cardiologist and a pulmonologist for our parallel respiratory analyses because we wanted to know whether it was even really worth looking at this. And the short answer is it takes decades for an association to develop between cigarette smoking and things like MI and stroke. And we don't know about the mechanisms if there is an increased risk of ENDS use leading to those, but that is a big kind of asterisk on our findings that it could take much longer. We still felt it was important to do the analysis because I think this is the longest follow-up period that any study has looked at to date. But it's definitely, we're trying to be very careful when talking about our results in terms of in this 5-year period, we didn't see an association. And we did for cigarettes, right? After we excluded the people with prior diagnoses, we still saw an association for cigarettes over this 5-year period, but none for ENDS. But I think it's very important to think about kind of the mechanism when we're interpreting the results. Anything you want to add to that, Steve?
Sure. We've been doing analyses kind of parallel. So we're looking at cardiovascular disease outcomes. We've also been looking at respiratory disease outcomes. And when I talked earlier about the functional form of pack years, what I mean is that it actually looks different depending on the outcome we're looking at. So for cardiovascular disease outcome, it does go up and then decrease at some point. So it looks like a quadratic a little bit, but that's because I think there's an understanding that after people smoke, quit smoking for a period of time, their cardiovascular outcome starts to decrease. So the risk of a heart attack is lower for former smokers. For respiratory disease outcomes, it's much more cumulative. It doesn't have that decreased effect, so we use a different distribution. But we have spent a lot of time trying to model it correctly because kind of the risk of smoking has a different impact depending on the outcome we're looking at. So for MI and stroke, we did do things like look at the take the quadratic, and it was significant, but that's because a lot of people quit smoking. Yeah, and it's a good point, and something that we have to be careful about. And it's not just having the right variables, it's kind of modeling them in the correct way to make sure our results are not biased.
You're muted, Ritesh.
There's another question. Sorry if I mispronounced your name again. Tan Huen Vu asks, what about the use of other tobacco products such as pipes and cigars?
That's a great question. We didn't plant it, but that's what we're doing next. So actually, our much larger focus as a part of our Tobacco Center of Regulatory Science is on poly-tobacco use. So Steve, I'll let you talk about kind of our plans for next steps, but we already have some current youth analyses that are pulling in other combustible products and looking at respiratory outcomes, and we plan to do something similar for adults.
Yeah, absolutely. We're looking at poly-tobacco use and the impact of different tobacco products. And the study is constrained by just looking at tobacco smoking or cigarette smoking, but in subsequent analyses, we're going to add to that. We're specifically focused on COPD as an outcome. You'll note, our issues of statistical power is not just related to ENDS use, it's related to like the small number of outcomes in general. And we definitely, if we start to look at poly-tobacco use, there's a problem with like 0 cell sizes that preclude some of these analyses. But that's our idea, is to look at the effect of different tobacco products and next steps.
Well, I think we are at the end of the hour now, and we want to be respectful of everybody's time. We thank Jana and Steve for a wonderful presentation, and all the attendees, we thank you for your presence here, and we hope to see you, that you will accompany us again in our next webinar. So thank you very much and good afternoon.